Hello. In this video, we're going to address 3 questions from a student. One of them is about a question about just how do we leave an answer. That's the first one here. And then 2 are questions that concern ourselves with factoring techniques. So first, let's talk about number 1. So the question from the student was, if I have a radical answer, should I leave it as a radical, simplify the radical, or give an approximate value? Now, if you're in my grade 10 class right now, I really want to stress that we haven't actually covered radicals. So you don't have to understand what one is, or you don't have to know how to change its form. We have actually seen some students use radicals because people learn them, and they're useful. So simply put, a radical is a situation where we have root of some value. So we could say that root 50 is an example of a radical. So that's an example of a radical, and when the student talks about should I simplify the radical, what they mean is, should I write it as what's called a mixed radical? And a mixed radical is where we break the value up into the product of 2 numbers, one of which is a perfect square in this case. So if we can say 50 is 25 times 2, so I can say that's root 25 times 2, and then we can break that up into root 25 times root 2, which simplifies to 5 root 2. Alternately, we could write root 50 as, we could get our calculator out, and we could say root 50, and we get about 7.07. Don't forget that approximate symbol. So the question is, the student's asking is, can I leave it like this? Do I have to write it like this? Or can I write it as an approximate value? So at our stage, I expect you to either leave it as the answer here, so root 50, or if there's some reason to, we can convert it to a decimal. We don't actually have to know how to do this process of converting it to a mixed radical. If you know how to, go for it. This is actually a really useful technique, and it's worth developing. It's not that tricky once you get the hang of it. So, next question. There we go. My OneNote's just being a little laggy here. So we want to determine all values of p so that each trinomial is a perfect square. Now, this is part A of this question. So remember, a perfect square trinomial is a case where I have x plus a squared. So if we expand this out, we end up with x plus a times x plus a. And I can expand this so I get x squared plus ax plus ax plus a squared, and I have x squared plus 2ax plus a squared. So when we talked about factoring, what we said was decomposition will always work, but there are these special cases that we can look for and then find really quick shortcuts. And one of those is a perfect square case. Now, I'm dealing specifically with a perfect square case where the leading coefficient, that is the value in front of the x squared, is 1. And what we notice is that if the c term is a squared, the b term is 2 times a. So with this question, if we have x squared plus px plus 16, we want to find the value of p. So let's just change colors here quickly. Oh, a little. Oh, there it goes. Draw. So we're looking specifically at this 2a. This 2a is represented by the p, and I seem to have trouble changing colors today with my OneNote. Let's try this again. And there we go. The a squared is the 16. So we can do a little rough work here. What we're going to say, if a squared equals 16, we know that a is going to equal, and again we apply the inverse to both sides, inverse operation, so the inverse of square is square root, so we get the square root of 16. But remember, that critical idea we talked about is that if I have to actually write the square root, I have to put plus or minus here, so I get plus or minus 4. So if a is equal to plus or minus 4, and p is equal to 2a, p can equal to 2 times 4, or p can equal 2 times negative 4. And so in this case we get 8, in this case we get negative 8. So therefore, the two possible values of p such that this is a perfect square is negative 8 or positive 8. So this could be x squared plus 8x plus 16, or it could be x squared minus 8x plus 16. And we could factor this first one to x plus 4 squared, and we could factor the second one to x minus 4 squared. Okay, let's look at this last question here that the student sent. So he asked, is it okay if I change this question to negative m squared plus 5m plus 14, and then into m squared minus 5m minus 14? Well, kind of on the right track here, but the problem is that I agree 100% that I would actually rewrite this as negative m squared plus 5m plus 14, and the reason why I would do that is because I like my general form is ax squared plus bx plus c. However, what I can't do is I can't change the sign of each coefficient, because remember, this is an expression, not an equation. So what I need to do here is I need to factor this as is, or I always like to, if I have a negative as a leading coefficient, that is the a, I like to factor that negative out. So I could do this. And then I could now I can see that the product is 14, because 1 times 14 is 14, and the sum is negative 5. So we know that two numbers that add to negative 5 but multiply to give me positive 14. Oh, pardon me, I made a mistake here. I almost missed that. Product's negative 14. It's going to be negative 7 and positive 2. So I can apply decomposition, of course, here. M squared minus 7m plus 2m minus 14. And now I'm going to apply factor by grouping. And remember what factoring by grouping is, where I factor the first two and I factor the second two. So we keep going here. So we're going to get m bracket m minus 7 plus 2 bracket m minus 7. And I feel good because those binomials match. And then I factor those binomials, so I get negative 1 bracket m minus 7, m plus 2. And of course we have some extra brackets there, and that factors to negative 1 m minus 7 times m plus 2. Now, of course, a lot of us would just go right from this step to this step here, which is perfectly acceptable, but remember, the process of decomposition will always work. Now, bearing this in mind, there's actually no problem. So let's go over here in a different color, and let's do this in a slightly different way. So some students would actually not factor out this negative, and adults too, so I use the word students, but I should say other people might not, in which case product is negative 14 again, because negative 1 times 14 is negative 14, and the sum is 5. So the two numbers there are going to be, our two numbers are going to be positive 7 and negative 2. So if I apply the process of decomposition, I'm going to factor by grouping. And again, my binomials match. And I'm doing this pretty quickly here. So I factor positive 2 in the second one, and so I get negative m plus 7 times m plus 2. Which we can see looks very similar to what we have in gray over here. The only difference is if I factor negative 1 out of that first binomial, I get m minus 7, and then I have the same thing. So really important with this question is that if I agree 100%, if I was given this, I would completely agree that I'd go and rewrite it like this. However, you can't just remove that negative. You have to actually either factor it out and then keep it there, or you need to factor the trinomial with the negative there, in which case you could end up with this, which is perfectly valid for all intents and purposes. But I'd say a good kind of habit to develop is that if your leading coefficient is -1, just factor it out and work with it. All right, hope that helped.